Welcome to the Michael Shermer Show. I'm your host, Michael Shermer. This episode of the show is brought to you by Wondrium, which is a new configuration for the Great Courses, expanding their online and streaming content from courses taught by professors, like yours truly. I have two of them myself, and hundreds of other courses and documentaries and films and both video and audio content of all kinds. It's really cool. It's a great system. You can access the site and all their content online at your laptop, on your digital platform, or on your phone. Like in my case, you just touch the W app there. It pops right open to, well, this one I happen to see just a course I think I want to take. You can scroll through and just see all the different courses that are available here. But this one in particular, I don't know if you recognize this character there. That's Princip. He's the assassin that shot the Archduke Franz Ferdinand in 1914 in Sarajevo that triggered the First World War. That indeed is one of the crimes of the century. Anyway, this is a course that you can take. I'm going to take. Lectures are about 30 minutes each. Listen to them at 1.2 or 1.3 speed. You can plow through them about 20 minutes. So on a daily commute or workout, you can get 2 or 3 lectures in and get through a course. In this case, 12 courses, just a matter of days, and lots of great content. So here's the deal. By accessing it through my podcast, you get a free month of content consumption. So check it out. It's wondrium.com/Shermer to get your free month of content consumption at Wondrium. So it's Wondrium, WONDRIUM.com/Shermer. Wondrium.com/Shermer. A full month of free content, and then you can cancel after that, or just subscribe. It's great. I do, and you should too. It's just a great source of being an autodidact and teaching yourself. All right. Thanks for listening to this episode. My guest today is Michael D. Gordin. His new book is On the Fringe, Where Science Meets Pseudoscience. Michael is the Rosengarten Professor of Modern and Contemporary History and the Director of the Society of Fellows in the Liberal Arts at Princeton University. He specializes in the history of modern science in Russia, Europe, and North America, in particular on issues related to the history of fringe science, the early years of the nuclear arms race, Russian and Soviet science, language and science, and Albert Einstein. He's the author of The Pseudoscience Wars, Immanuel Velikovsky and the Birth of the Modern Fringe, Scientific Babble, How Science Was Done Before and After Global English, and Red Cloud at Dawn, Truman, Stalin, and the End of the Atomic Monopoly. So we cover a lot of big topics here that I've covered before on the podcast, mainly the demarcation line, the demarcation problem. Where do you draw a line between pseudoscience and pseudoscience? Not always clear. In fact, it's almost never clear. And as he likes to say, no one in the history of the world has ever identified as a pseudoscientist who's going to go down to his pseudo lab to conduct some pseudo experiments to support his pseudo theory. Nobody thinks that. So how do we distinguish between the mainstream and the fringe? And what happens when the fringe becomes the mainstream? What happened to the old mainstream when they were wrong? How do you know when somebody's wrong? So these are really important issues, not just historically, which is the book has a lot of historical examples, but currently, how do we know we should wear masks or not? Where the coronavirus really came from, a Wuhan lab or not, or some modification of that, and why should we trust the CDC or Anthony Fauci, and and on and on. So beneath those kinds of specific questions are larger issues about how science operates as a social institution, why we put our trust in scientists or don't, because they don't always get it right. And so we discuss those issues, as well as to what extent science operates by falsification, that is, trying to falsify theories. The ones that haven't been falsified are the last ones standing, so we accept those as provisionally true. Or, more likely, scientists act more Bayesian, that is, we try to pile up evidence in favor of the theory, and the more you have, the more likely you are to gain acceptance in your community of scientists, so forth. And then we get a little bit into politics in science, and religion in science, and postmodernism, and how this has played out historically and all the way up to the present. Some of the current controversies, and then we end talking about some of the bigger issues of how science can deal with conceptual problems like the hard problem of consciousness, free will, and determinism, why there's something rather than nothing, where the universe came from, those kinds of things. And then finally, how to talk to a climate denier, an anti-vaxxer, a creationist, a Holocaust denier, a GMO denier, a nuclear power denier, and so forth. How do you talk to somebody that denies the mainstream of science? Because, they might be right. So it's always good to keep an open mind. But on the other hand, most of the time, people on the fringe turn out not to be right. So it's good to be skeptical. All right. So with that, I give you Michael Gordin. Michael Gordin, nice to have you on the show. I'm a longtime fan and reader of your works. Your new book is On the Fringe, Where Science Meets Pseudoscience. As you know, that's what we do at Skeptic Magazine. That's kind of my day job, so I've spent a lot of time on this, including discussing on the podcast. But it seems relevant to me, even though a lot of your book deals with famous historical cases of marginal claims between science and pseudoscience. In fact, it still goes on. I mean, just, this morning there was stories about, whether the coronavirus came from a Wuhan lab or not, and whether we should wear masks or not once you're vaccinated. And should we trust, Anthony Fauci and the CDC, or should we not trust them? Who should we trust? Who's the scientific authority? Or just pick climate change. Why should we accept the climate consensus of the experts? Who says they're right? What about that famous climate scientist I see on TV all the time, Richard Lindzen from MIT? He's an authority. Why don't we trust him? And so on. I mean, it's quite relevant to current events. So. But before we dive into your book, give us just a little bit of background, where you grew up and where you went to school and how you got interested in the history of science and pseudoscience and all these interesting ideas.
Well, first, thanks for having me on. Also a longtime fan and a longtime reader. I started, I suppose, I'm a historian of science. I teach at Princeton University, and the path here is, I guess, similar from many historians of science in that I thought I wanted to be a scientist, specifically a physicist. And along the way, I discovered the history of science, which melded a long-standing interest in history with a deep engagement with the epistemological and theoretical concerns of the sciences. And that's the sort of trajectory in the professional career. I've worked on history of nuclear weapons and a bunch of other topics, but the history of the fringe, the things called pseudosciences, has been a long-standing interest. That goes back to middle school, when going to the public library, you find the section on science, and it has lots of really cool stuff. And then it has a lot of stuff about UFOs, which is another topic we could get to, I suppose. Various other theories on the edge. It's next to the stuff about FBI fingerprint labs and so on. And I just devoured that material. And then when I started doing history of science research, these questions about the border between what counts as legitimate and not legitimate science, they're just endemic in the history. There's no point at which that's not a live concern. And they've always fascinated me, in part because I never found a philosophical way of doing it that cut right. So history gave me a lot of guidance in trying to think about what place scientific authority has in our society. How do scientists themselves make decisions about what's a credible claim to investigate and what just isn't worth the time? And how those engagements can be communicated to the public at large. So I teach a course on the history of pseudoscience, which I've done several times, and this book grew out of the experience of teaching that class, where the goal was to teach people the history of many important episodes in that history in order to get them to understand how science works a little better, because you can't look at one without also looking at the other.
Yeah, it's a point we're always making at Skeptic Magazine and Junior Skeptic Magazine, by the way, for kids, that we're not teaching you how to think about each of these claims, UFOs or Bigfoot or ancient aliens or whatever, but that demonstrating how to think about them such that when some new claim comes down the pike we can't even think of, some new conspiracy theory or some whatever fringe claim, then you can apply the tools of critical thinking and skeptical thinking and so on to the new claim. So for example, the latest row of UFO stories because of these Navy videos. There's 4 basic videos that our columnist and Metabunk director Mick West has been, analyzing very carefully. But even and people go, oh, come on, you can't claim that these are all balloons or all these are all just radar bounces or it's a zoom effect or the rotation of the FLIR camera or the bokeh effect of the lens aperture and so on. Well, but even if you reject all of Mick's explanations for them, what's more likely? Those are that aliens have landed here, which is an extraordinary claim, or that, even crazier to me, is that the people that think they're being more modest and say, no, I'm not saying it's aliens. It could be Russian or Chinese assets. Okay, so here's my analogy. What are the chances that the Russians and Chinese somehow managed to develop physics and aerodynamics like centuries ahead of us without us ever knowing? It'd be like we have biplanes and they have the stealth bomber. Or we're using rotary phones and they have smartphones, and somehow we completely missed out on this. And since you worked on atomic weapons, what was it, 4 years before the Russians got an atomic bomb after the most secret thing we've ever done, the Manhattan Project, and yet they stole our plans. I mean, this is how things normally go. Apple, and they sue everybody for proprietary protection of their intellectual property, and still every cell phone is basically the same.
And this is one of the things that I teach my students, and I think that the book also shows, is that there are way too many claims for anybody to debunk. And so what happens if you're a practicing scientist of any kind is you get tons of this stuff in your email. You even get tons of it in the published journals. There's stuff that's published that you're like, that's not right. And you have to decide whether you're going to spend time figuring out what the claim is, getting really up on it, and then debunking it, and then getting the debunking published, even though it's pretty hard to publish a negative result, like this also did not prove ESP, is sometimes hard to do. So you have to decide whether you're going to invest that or not. And often the way you do that is by looking at how the claim sits in the totality of other claims that we have. So as you said, it is imaginable that someone could develop, I suppose, a method of flying that seems to defy G-forces, etc. Could they do that without anybody else having hit on it and no one having heard of it through any kind of espionage or leak, etc., over the course of decades? And when you look at it that way, the web of interconnected claims is extremely hard to argue against. And that's the same point about climate change, that there's so many different parts that even if you disagree with this specific heat measurement, all the other parts really do fit. And you have to decide how to make that judgment. And that's how routinely stuff about ESP doesn't pass muster. It's the usual response is, why don't you just investigate it and prove I'm wrong? Well, that takes a lot of time and a lot of energy. Skeptics have done this for some time, from SciCop, the originating organization, and even before then, have done a huge amount of work trying to investigate those claims. But that's a fraction of the number of claims that are out there. So you have to decide, is it worth it? And the way you make that decision is based on how plausible is the claim, even understanding that scientists have a certain amount of lowering of the plausibility. They're interested in a new claim. They're interested in something that will push beyond the consensus. But there's a way they calibrate that with what's actually plausible. And that mechanism, that sort of dance, is what's been behind the negotiations of the border between the scientific and the non-scientific, and that which is called pseudoscientific, across the centuries, trying to figure out what that balance is between orthodoxy and innovation.
Yeah, I like William Ewell's consilience of inductions, or I just call it convergence of evidences from independent lines of inquiry. To counter this idea that scientists are either conspiring to get a certain conclusion for some political nefarious reasons, or they're locked in an ideological path and they can't even see their way out. That might be true for one small group of scientists, maybe working in the same field, even if in different labs, but different fields. These climate conclusions are based on a dozen different fields. Glaciology and cloud covers and computer modeling and sea level rise and CO2 gases and the flowering of plants earlier in the spring and butterflies and this and that, so it's not like they don't even know each other. They don't publish in the same journals. They don't go to the same conferences. So it's not like they can possibly be locked into some kind of ideological trap like that.
I mean, there are two qualifications on that. One is the consensus is sometimes wrong, right? Like in the 19th century, the consensus was light waves move on the ether, which permeates everything, is all around. And that's not true. That said, it's not just Einstein who thinks it's not true in 1905. There's a bunch of other people who are questioning it, but the barrier to make that plausible was quite high, and Einstein met it. But you have to do a lot of work to show that you're worth being taken seriously, and he did that work. The second qualification about this sort of consensus of stuff is that contemporary science is organized in an adversarial manner. The way you get reputation, get hired, get published is by making a claim that is to some degree controversial, that refutes or engages with or sharpens a claim that already exists in the literature. So if it were the case that somebody was pushing a false claim that the planet is heating up due to human consumption of fossil fuels, lots of people would want to knock that down. And they've tried, and they haven't succeeded. And that adversarial structure is part of the reason why science is a robust system. It's also part of the reason this is a claim in the book. It's that controversial adversarial nature means that sometimes the controversial claim can spin off and become its own thing. Cold fusion, a bunch of ESP is another example of that, where something looks like it's plausible. Phrenology, eugenics, there's a bunch of these that they seem plausible. There's a fight, they lose the fight, and then what happens to the doctrine after it's dismissed by the mainstream? In most cases, it just goes away, but in some cases, it gets enough adherents who think that something wasn't taken into account or so on, and it can build its own community around it. Creationism was a plausible scientific hypothesis in the early 19th century, and it just isn't anymore, but it still has an infrastructure. The reason why I think it's important, pseudoscience is a topic people like talking about because it's exciting and interesting and on the edge, but it's a way to teach people how to think about how science operates normally, which is through these mechanisms of fighting back and forth, of claim and counterclaim. And then there's a lot of infrastructure built around that, publication venues, funding mechanisms, grant evaluations, all of those things. To some degree, they're barriers for inquiry because they knock out some interesting, innovative ideas or slow them down. But they're also ways of guaranteeing that which we think we know is much more stable than it would seem if it were just anything pops up at any point in time. And it concentrates our resources to the edges where we want to really be investigating.
Yeah, so this idea of consensus science and the consensus was wrong, we can only spot that with the hindsight bias, of course. After the fact, oh yeah, we can see how they went down the wrong path. Of course, it would be interesting to know which ones we're living in now that we just take for granted. And a century from now, they'll go, oh, look at those people in the early 21st century. They thought X. And now we know that's not true. So you must get these letters from people saying, I got this alternative theory of physics, and why won't anybody take me seriously? Or would you please read my paper and help me get it published or whatever? What do you say to somebody like that who they genuinely think that they're doing something? Oh, I was going to say, you have one of your quotes that I use in my lecture is, no one in the history of the world has ever self-identified as a pseudoscientist. No one goes down to their pseudo lab to collect pseudo facts, to test their pseudo theory, and so on. They all think they're doing something. So what do you say to somebody like that?
Well, the first thing, I think it's important to engage with that person respectfully. Not everybody agrees with that particular stance, but
no, I do.
The conversation doesn't always stay that way, and that's often where I cut it off. But I'm curious. What I'm interested in, and the first thing I say is, I'm not a scientist. I'm a historian. So the community you want to address is not me. I sometimes, if I feel like it's intriguing, I want to read it. I'm just kind of curious about how it works, and I often want to know how they came to it. Since nobody thinks they're doing pseudoscience, the person who thinks they've refuted Einstein, it takes them a while to get there, and I'm curious about the path that took them there. Like, what was the decision tree that ended up with this result? And I'm interested in that for my own selfish reasons historically. I've followed some of these people in the traces we have in the archives who have done that, and I'm curious about how people do it today. We don't have a lot of those traces because usually, your kids or your nephews throw out your stuff if you're that person. But sometimes we have tracks. So I try to listen to the argument, but often that happens less often than you would think, because if you're someone who has published a book or two with the word pseudoscience in the title, usually people who have been called that don't like engaging with you. And an example of that is there was a lab on Princeton's campus called the PAIR Lab, Princeton Engineering Anomalies Research Lab. It was here from 1979 until 2007, investigating ESP type things, whether humans can affect machines with their minds. I always wanted to visit it. I never could because I was associated. I'm the guy who teaches that History of Pseudoscience class, and the director didn't want me in it. And that's a shame, because I got asked about it by students all the time, and I also really wanted to see how that path happened. But because they've been treated quite badly and dismissively by a lot of people, they are gun shy, and that leads to another feature which you see in a lot of cases, which is a desire to create your own community, and in some cases a quite robust community. So the creationist is the most elaborate of these, but you have groups of people who have their own journals and their own conferences and their own workshops. You see, Flat Earth is probably the most recent kind of efflorescence of this. That's a fascinating phenomenon. It's not just that they actually care about the natural world. They're not approaching it the way the consensus would, and they're not getting results that you or I or many other people, most other people would think are credible, but they think they're getting at something, and they think it's important to do it together. And that's a fascinating phenomenon. I don't know whether it's increasing over time or decreasing over time. I don't think it's decreasing over time. I think there's two positions. Either this is a constant phenomenon that's been happening always, and we can now see it better because of the internet and other lower barriers to communication, or it's increased because of those lower barriers to communication. I don't know what your position is on that, whether the situation is worse or the same.
I think you're probably right that, and if you just look at like the history of the JFK conspiracists, they were mostly people in their garages with a mimeograph machine and just physically distributing leaflets and meeting at hotel rooms in a small, 15, 20 people or whatever. Now you could just set up a web page and you have, 1 million viewers in 10 minutes or whatever. The barrier to access is so low now. Anybody could create pretty much anything they want. And they do. I mean, some of them are just fantastic web pages. We ignored the flat earthers for the longest time until and so here, our decision whether we should cover something or not is largely based on to what extent there's a lot of public and media interest in it. And, all of a sudden, boom, I don't know when it is, maybe 2012 or 13, or the flat earthers just erupted on the scene. And then there was some, I think Joe Rogan had a few of these guys on and talked about it. And then there's that Netflix documentary you referenced, Beyond the Curve.
Yeah.
This was a gripping film from a sociological, anthropological point of view.
Yeah.
This guy, I forget his name now, but he's sort of the hero of the movement. And he's like the Einstein, like, I have this truth, and he's swamped by all these groupies, and it's like, all right, I see this, it's like he probably can't get attention outside of that, but in that community, and they all, there's sort of an internally coherent and consistent logical arguments that they all share, that it kind of emboldens them to this kind of alternative truth.
Yeah, it's the interesting choice about whether it gets a lot of public attention is one. I mean, I feel like I should be asking you a lot of questions about this because you are engaged with it in this way. I sort of divide many of these doctrines as to those that cause significant public harm and those that don't. And I think that the number in category 1 is pretty small by my estimation of what that would be. And there's a broader question about how much people should be upset by the fact that there are flat earthers or Bigfoot theorists or stuff like that around. And the historian hat is to be agnostic about whether this is good or bad, and just notice that there's a sort of shape to it. There was a big efflorescence of these things in the early Cold War, 1950s. You get a whole spate of alternative theories that imagine themselves to be heterodox. And then you have a whole bunch of them that are happening kind of in the early 21st century, like now. There are other moments where you see quite a bit of them. The 1860s, 1870s has a lot of them. There's a bunch around the time of the French Revolution. So from my point of view, it's like, what's happening at those moments that make people feel like the consensus, the establishment, whatever you want to call it, isn't doing it for them. It's not succeeding, and that they have an opening for their point of view. Because again, they don't think they're pseudoscientists. They think they're scientists. So why does it collectively have that structure? Why are the JFK assassination theorists can only happen after JFK is assassinated, but it also has a shape. There's moments when that's a better theory or not. Shakespeare authorship controversies happen at different times. And they're always there, but they flare up, and the flare-ups are intriguing. And coronavirus has been a moment when there's been a flare-up. There's a lot at this moment.
Well, in the case of the JFK, that was Oliver Stone's film, launched it into the stratosphere right around the time the internet was getting going, and so that that double whammy, and shows the power of visual medium. Even though I didn't really have a dog in the fight, I didn't really care, hadn't studied it that much, but after seeing Stone's film, I thought, oh boy, if only 10% of this is true, then for sure there was a conspiracy. It wasn't until later when people deconstructed every scene in the film and said, well, he's lying, he made this up. Like he had this thing about Oswald couldn't hit Maggie's drawers. He was such a terrible shot. And Gerald Posner went and got his Army record, his riflery training, and he was like the second highest you could score. It's like, oh, okay. So there's this falsehoods being promoted. But the film, that idea that things can take off like that, makes a big difference. So let's do a cut there from dangerous, not dangerous. I think that's important to make. So anti-vaxxers, climate deniers, Holocaust deniers, creationists who want to get their doctrines taught in public schools. To me, these are things we really need to address.
I've actually been on the fence about the creationist one. And the reason there's sort of 2 points here. I actually was taught creationism in a public school, even though it was illegal at the time. Like my 7th grade teacher in social science actually taught it to us. And it was just like he taught us the evolution stuff he was supposed to do, and then there was he had some Xerox segments of what I now know is a creationist textbook. I didn't take that part seriously. I thought he was for some reason required to do it, but of course he was required not to do it, and he did it anyway. But how dangerous is it? So there's at least probably more than this, but there's at least 2 planks. One is it's a principle about religion in the schools that is important to enforce. That's one point. But the question of how damaging is it if more people don't think that Darwinian evolution works, does society stop? Or does something catastrophic happen? I'm not convinced of this, although I've had students who were also taught creationist stuff and were really upset about it. They were mad that they had been exposed to this as though it was true, and that they were all science majors. It didn't hurt them in the long run, but it clearly they resented it as a point. But is that as dangerous as, say, anti-vax? And I don't know. Creationism is a border case for me, so I can see how it would work in both cases. It's certainly the best documented, the largest, and the best funded of any of these fringe movements. So it is a kind of gorilla in the room for any conversation.
Yeah, I guess I agree. It's not clear. The counter argument to that would be, well, these are gateway drugs. Who cares if somebody reads the astrology column, or they spend the night in a haunted house, or they go looking for Bigfoot? Yeah, but people that believe that or accept or go down that pathway are then also more likely maybe to accept QAnon and the rigged election conspiracy theory, or that vaccinations cause autism or whatever, and that we should halt it, draw the line earlier rather than later.
I think that's a very valid point. It's not just that there is clearly an effect where if you believe one theory, you probably over time will believe more than one. It's not common for someone to be, I'm just a UFO person and I don't have any other theories that are outside the orthodox. I have a sort of basic belief about that, is that once you kind of ratchet up your skepticism towards the consensus on one issue, you're ratcheted. So you're willing to entertain more outside the box arguments because you've done so already once and you don't feel that same barrier. And also, once you're in part of a community, like once you're in the UFO community, other people in that community introduce you to new things. And so the community effects are strong. But I've noticed a structure sometimes. Like, I spent a long time studying, and you know this, Immanuel Velikovsky's theory of cosmic catastrophism, of like that Venus was a comet that almost hit Earth. So the people who believed that, not all of them, but a subset of them, also didn't think that Shakespeare wrote his plays, and also thought that the Kennedy assassination was a conspiracy. And there's no reason why those three should go together. There's nothing logical that requires it, but they seem to group. And I've long been searching for some plausible explanation of why there seems to be affinities among some of these and not others. It should say that conspiracies actually do happen, right? Like Watergate happened. So, and that also colored people's willingness to believe in the JFK assassination. They're like, a conspiracy is possible. Although the other lesson of Watergate is a conspiracy is possible, but then it's also exposed. So it's hard for a conspiracy to stay secret for a very long time.
Yeah, this is my next big book on conspiracies and conspiracy theories, which I just finished. And so I've been giving a lot of thought to this. You know, there is some research on this. There's a famous paper called Dead and Alive. I think it's Karen Douglas. Anyway, the people that tick the box that they think Princess Diana was murdered are also more likely to tick the box that she faked her death and is living somewhere, you know, with her lover or whatever. And well, she can't be both dead and alive, right? So, but the interpretation here is that these are proxy beliefs for something else. That, you know, I don't trust authorities. I don't believe the first thing people tell me, especially if it's a large corporation or a major government agency or something like this. They're always bullshitting us and lying to us. You know, Watergate, the Pentagon Papers, WikiLeaks, you know, conspiracies happen all the time. You know, I'm just going to default to being a little on the paranoid side and just not believe stuff. And, you know, there's reasons for that because, as you said, you know, a lot of these things are real. And so it's not completely crazy when, although Alex Jones is completely crazy, but, you know, his false flag operation, inside job. There are false flag operations. There are inside jobs, you know, and the Pentagon Papers showed how much all our government was lying about the Vietnam War, and WikiLeaks showing, you know, these warrantless wiretaps and so on, and surveilling foreign, you know, Angela Merkel's cell phone. It's like, what? What? So, you know, there's kind of a deeper truth.
But this is part of the reason I'm interested in this boundary between science and the fringe, however it's defined, conspiracy theories, pseudosciences, etc., is exactly what you said. Like, it's the skepticism. Skepticism, as you would certainly know, is a value in science. It's like one of the things that science is supposed to do is be, as the sociologist Robert Merton would say, organized skepticism, right? Like, so the fact that skepticism has this double-edged quality, that it is both something that scientists are supposed to do, but it's something that also works against the consensus of science in these other alternative fringe movements. There's something about that is why I think it's so plausible for someone to say, I'm not a pseudoscientist. What I believe is not orthodox, of course, but the flat Earth has all these arguments for it, and that's why I believe it. And it's because I'm skeptical, which is what people like Michael Shermer told me to be. So I can see how the tension exists there.
Oh, I get emails all the time. Shermer, you're a skeptic. Be skeptical of climate change. Come on, look at all this and this and this. And, you know, back to the Velikovsky story in your previous book on that, you know, people probably forget this now because that was so long ago. But, you know, it was Carl Sagan who finally said, all right, I'm going to take it seriously. I'm going to do the math. I'm going to check all the claims. Boom, boom, boom. Now, you know, does that really matter? Well, yes, it matters to people who might be willing to accept it. And then they see the skeptic explanation, go, oh, okay, never mind. It's probably not that. You know, so it serves that role. But of course, Velikovsky thinks he's a good skeptic of the mainstream astronomy, astronomical explanations of the solar system, and so on. So, how do we know when a scientific community is doing the right thing and that the fringers don't turn out to be right? I mean, let's go back to Einstein, and you have this whole section on Aryan physics, German physics, and Philip Lenard. And to what extent Einstein was not taken seriously at the beginning, and then how did he get acceptance all the way up to the Eddington eclipse experiments, which are also kind of misinterpreted today. Like that confirmed it that Tuesday, at 3 o'clock, the eclipse, boom, Einstein was right. Well, no, that's actually not exactly how it worked. So kind of walk us through that period and show that kind of balance.
So this is a stop me if I'm getting well into the weeds here. But there were a bunch of problems with ether physics as understood. It was universally basically understood that light traveled on a universal ether because all waves have to travel on a medium and light is a wave. And so they tried to figure out its properties. And if it's a medium that we are traveling in, we should be able to detect its drift. And the attempts to do that failed. And Einstein knew about some of those attempts. He didn't know about the best of those, which is the Michelson-Morley one. But there were other internal reasons why people were unsatisfied with the ether explanation, but there wasn't a good alternative to come up with. And a couple of different people came up with a mathematical treatment. The most famous of these is the Lorentz transformations by Hendrik Lorentz, Dutch physicist. And Einstein derived those without an ether assumption. And he was published in the Annalen der Physik, the leading journal in German physics, which was the leading community of physics at the time. And it was published basically in part because there's no peer review process back then. The editor, Max Planck, thought it was a really interesting idea. He wanted to see it published, so he published it. There was a debate at the time, and different people thought different parts of this theory. They accepted some of it. It was a better derivation of the equations. They weren't sure whether you needed to get rid of the ether. So the ether kind of lives on as a hypothesis for a couple of decades. It's by the end, by 1920, though, it's very rare to see someone seriously take the ether as existent, but it took a while to die. It wasn't like 1905 and a switch is flipped. And Einstein then extended his special relativity into general relativity. There was a very public eclipse expedition in 1919, which in the court of popular opinion meant that general relativity is true. The actual confirmation of the bending of starlight took quite some time, about half a decade longer, largely with American observatories doing very detailed precision work, but ending up confirming the theory. So by the time we're at 1930, relativity theory is broadly accepted. Ether physics doesn't really exist much anymore, except on the very far fringes, and you just don't use it. You don't need it for the science you want. And there were, around 1920, very prominent critics of Einstein. They formed an anti-Einstein league, and they attacked him once he started before he became famous, but after he became famous a lot more. It's mostly an anti-Semitic movement. It's not very big, but it has some people with credentials in it. And it's mostly anti-Semitic. It's very anti-pacifist, and Einstein was one of the most well-known pacifists in German space at the time. And the most prominent members that grow out of this are Johannes Stark and Philipp Lenard. Philipp Lenard made his reputation measuring the photoelectric effect, and he won a Nobel Prize for that, which is ironically the thing Einstein explained in 1905 that ends up leading to his Nobel Prize. Stark discovered the Stark effect about the splitting of electric lines, of spectral lines in an electric field of atoms, and which is an important quantum effect. Lenard and Stark dislike Einstein. They're in favor of Hitler even before 1924, even before Hitler attempts to coup in Germany. They're very strongly Nazi. When the Nazis take power, they try to capitalize on this older anti-Einstein movement and their hostility to relativity physics and quantum physics and try to create a thing they call Aryan physics or German physics, depends how you translate it, which is basically a return to classical physics, very rigidly into classical physics, rejecting all this other stuff as Jewish physics, as pseudoscience, as not real. And so they use the same rhetoric of pseudoscience that you often see against other people. They try to get this established as the way physics is to be taught in the Third Reich, and it fails. It fails because other physicists like Heisenberg persuade the Nazi state that you actually need competent physicists if you want to do the things you say you want to do, and this stuff isn't competent physics. So the movement ends up foundering even in a very politicized, highly anti-Semitic, and highly anti-Einstein specifically context. So the compromise that they end up coming with is you can do all this stuff, you just can't say it's Einstein. And that's where Aryan physics basically ends. But it was an attempt to try and leverage a political regime's ideology in order to intervene on what was perceived as intra-scientific disputes. And everything in Aryan physics is actually legitimate science. It's just legitimate science from 1870. It's out of time as well as noxious ideologically. That's a brief version of that. I hope it got to what you wanted me to get to.
That's perfect. This is all played out quite nicely in that 10-part Einstein series based on Walter Isaacson's biography of Einstein, and where they at the very end, Lennart is with the Third Reich collapsing around him. He's gathering his papers like he's the last of the Aryan physicists to go. It does seem like Einstein was a special target, not just because he was Jewish, but also because he's famous. I've noticed this just in the last 30 years since I've been doing this. People that stand out, Carl Sagan, Stephen Jay Gould, in say the 80s and 90s, people just target them because they're big names. You can pick other people, maybe right. Stephen Hawking now, and and a few other famous people. So there's that too. It seems like there's kind of a pecking order hierarchy. Lennart was, on top, and then here comes this Einstein guy. It's like, okay, he's getting. In the film, they show this dialogue where he's complaining to his wife about now the press is asking, about his hair and what he eats. This is disgusting. He's just, So I do think there's some of that too. Maybe just good old fashioned jealousy.
No, I think there's two things there. One is the jealousy point, the fame part, and a sort of feeling that I was once at the top and fighting a rearguard action as science moves from under you. I mean, this is something I think underappreciated when people think science is a stable entity. This dynamic quality of scientific thought means by the time you retire, the things you built your reputation on may very well be rejected. You've lived through a career where you advanced the frontier of science, but then it moved beyond you. And that's a sort of poetic way of thinking about the transformation. That's very different from, say, how historical knowledge gets built, where it doesn't get overturned quite so rapidly. But there's something about the fame that's, I think, even beyond just jealousy. There's long been a resistance to the mathematization of physics among the fringe, that something's wrong when the science is incomprehensible to ordinary people. Why do you need all this extra stuff that takes years to learn in order to do it? And up until through the end of the 19th century, that was a very common narrative, but it's all about Newton. It's like Newton is awful. He has made the science terrible, and we need to get beyond Newton and do something different. And then it becomes about Einstein. So Einstein just takes the place of the representative of mathematized science. That's because of fame. It's not like because these people are actually scientists who feel they're being displaced. It's more that the only scientist you can think of to tag that particular, who stands in as the icon of this math that you don't like, used to be Newton. Now it's Einstein. Then it probably becomes Hawking. But Einstein's still famous enough that it can still be Einstein, right? And when somebody comes who displaces that, there'll be a move for it. But Darwin was a lightning rod in his day for lots of attacks in a way that, as you know, Wallace wasn't as much. Wallace also had his own fringy ideas of various kinds, but people identified the science with Darwin specifically, even though there were a host of people pushing it forward. And he became the target that stood in for everything they thought was wrong.
So the other factors at work here then are, to somebody who's so-called on the fringe, well, it may take decades before your theory can be proven or falsified. And furthermore, you got to do the work yourself. You can't just, hope this happens on its own. And maybe you have to publish 50 papers and you have to keep running experiments. And, it didn't happen overnight for Einstein. And so if you're using that model, well, look, Newton was right and Einstein was right. And I'm going to overturn both of them and, just continue. Well, that's really not how it works. You can't just say it. You have to have all these other structures in place.
And two classic examples of that get invoked are Continental Drift, which was broadly rejected when it first came out, and decades later with new evidence that Wegener wouldn't have even imagined possible, that we could actually measure the magnetic polarization of the seafloor, which is something we could do starting in World War II with submarines, made the theory come back. So Continental Drift gave what was cited a lot in the 70s among segments of the Fringe, being like, you see, you guys rejected something and it just took a few decades. The other classic example, and you see it invoked all the time, is Galileo, where he fought against the establishment and he was right. And the establishment was totally wrong and they persecuted him and you're persecuting me. And that Galileo trope is very seductive because he's one of the icons that everybody can agree is an icon. The scientists and the Fringe have different interpretations about what its significance is, but everybody agrees that he was right and the establishment was wrong to do what they did to him.
Yeah, I always, to those people, I would like to point out that what about Tycho Brahe's alternative solar system, where all the planets go around the sun and that whole system goes around the Earth? And you know, that was also challenging the mainstream and the dogma, and yet he was wrong, so we don't remember him for that.
Yeah. And also the reasons why Galileo was, this gets into the weeds again, but Galileo's wasn't persecuted because he argued the Earth went around the sun. He argued that he was persecuted because he couldn't prove that. So he made that claim, and they're like, look, the church has, the Jesuits in particular have a huge scientific apparatus going on in the 17th century. They're doing a lot of stuff that's establishment science. They're like, well, if we have to change the interpretation of the Bible, we'll change the interpretation of the Bible, but show us it's true. And Galileo had a theory of the tides being caused by the rotation of the Earth, which is just wrong. It predicts the opposite of what actually happens. And so not to say that it was right to put Galileo under house arrest at all, but Galileo was given an opportunity to make an argument, and he didn't succeed in making the argument. That adds a nuance to it where Galileo was correct, and he had other reasons that they didn't find persuasive to think that the Earth went around the sun. But when he staked everything on the tides, that was a mistake.
Can you get a theory accepted without an underlying mechanism? So, for example, Wegener shows the continental drift theory based on the kind of puzzle it looks like they were once one giant landmass, but he didn't know what could possibly push an entire continent. Nobody did. And so that took decades to figure that out. There's these giant liquid cells underneath that are rotating, and they're pushing the continent plates that are sitting on these larger cells underneath, and so on. And that's not until the 1960s. But on the other hand, Darwin's theory was accepted long before Crick and Watson showed the DNA mechanism underlying the genetic code by which natural selection can operate. So natural selection is not a mechanism, it's a description, and that all was fully accepted before there was an underlying mechanism.
And the even more classic example of this is Newton's gravity, which is just an equation. And people are like, well, but how does it work? What is the thing that keeps things apart or attracts them together with this 1 over radius squared strength? And it not only so he proposes it's accurate, but the entire trend of natural philosophy in that period was towards mechanistic explanations. Descartes had a whole series of explanations of little atoms pushing things around, and that explains why things move in ellipses. And Newton was just like, no, we're just not going to do any of that. We're just going to get a description that works, and we're not going to worry about the mechanism. And that was a fight at the time, and eventually everybody's like, well, it really, really works, his theory, so we're just going to bracket the mechanism for now. And that's so you see this in many cases. The thing with Galileo, they could have accepted it without a mechanism, but what their position was, and this actually strikes me as not a crazy position, is look, they're mathematically equivalent. They're just transpositions of each other. So in order for us to make what's potentially a destabilizing public proclamation that in fact we're whizzing through space, we actually need to prove that, but or at least like make a really concrete explanation to people. And what we can do without that is we can do all the calculations using Ptolemaic astronomy. There's nothing, we can still navigate our boats, nothing changes. So we only want to make the realist claim that the world is actually different when we have a mechanism. And sometimes that matters and sometimes it doesn't. The Darwin example is also a really good one for that.
This is why I'm not sure what to think about string theory. Of course, it's not pseudoscience. It's not math. It's not metaphysics. It's mathematics. But at some point, is there something out there that actually corresponds to these massive equations? Like on line 7 of equation 32, there's these itty bitty little bits out there in the real world, and somehow we can measure them, and then that will confirm the mathematics. Or is it forever going to be? We're so far down the rabbit hole of conceptual physics that's pure mathematics. People like you and I will never know if it's true or not. We're just going to have to base on what the consensus of the people that do it tell us. Yeah, it's true or it's not true.
Right, and you could see why that rankles to somebody who's like, I thought I was supposed to understand how the universe goes, and not only is it a lot of math, it's so much math that it doesn't even correlate to anything else. String theory is an interesting example of this kind of part of the reason I use the language fringe is that like there's stuff that's on the fringe of acceptable knowledge that's actually a candidate for becoming scientific mainstream. And string theory is that. When it was first formulated in the early 70s, it was pretty out there. And it's not until a couple of mathematical innovations in the mid-80s that it becomes a real candidate for a theory that would unify the four forces of nature into a big theory of everything. And it had a very good run in the 90s, and then it hit a bunch of hiccups in the early 2000s, and now it's in a strange position. It's still very prominent, very mainstream, but it's facing more contenders. And usually now I've seen a rebranding over the last decade where they don't call it string theory, they call it quantum gravity. Because quantum gravity is a little more capacious. There's a bunch of different ways you can do it, and it doesn't sound as silly to people as string theory does. But the string theory was on the edge, then it became in the center, and it's always potentially going back and forth to the edge. Lamarckian inheritance also has this quality where it's sometimes out and sometimes in and sometimes out. And that both that expresses the dynamism of how science works. It has to have an edge, which is a little riskier, or no new ideas are ever going to happen. At the same time, that edge has a lot of weird stuff at it that you don't want to let into the mainstream. And the difficult decision of let's take this really weird idea seriously, like people who are looking for like non-conventional propulsion mechanisms for long-distance space travel. You have to take some really weird ideas seriously if you want to make progress there, but they're pretty weird. And so you're going to waste a lot of time, but it might be worth it in the long run. And different scientists make different calculations about how much of my own time and energy and brain power am I going to put into this thing that might yield no results at all. And there are some people whose personalities go that way, and some people's personalities don't. And that's the scientific community. It has a complexity to it that enables some people to bring in the really interesting quantum gravity, way out there ideas, and other people who are happy to work on laser optics and just doing stuff that's much closer to establishment. And that dynamic is very visible, certainly over the last 2.5 centuries, in part because the mechanisms we've set up of adversarial science, competitive publication, and the increasing expense of doing science at the edges have constrained resources and attention such that we really do have to make hard decisions about how much we're willing to risk here or here.
Well, that's why you have DARPA or the Google X projects, and you just set those aside. They probably likely will lead to nowhere, but maybe 1 out of 100 will become some breakthrough technology. I do remember reading when Hawking said he discovered that black holes radiate. I thought he discovered it. You mean like through a telescope or something? No, just pure mathematics. It's like, how is that a discovery?
Yeah. And then the very idea of the black hole was super weird around 1950 or so. And then Oppenheimer has an early paper where he's like, maybe such a thing could exist. And now it's not only that they exist, they're common. Like every galaxy has one in the middle of it. Like it's just like these things are, it's astonishing to see how such a really fringy idea became super mainstream. And it's a sign that the fringe is not all bad, right? Like it has stuff, it's a place that generates new ideas. And you just got to figure out how not to waste time and energy sifting between those. And does that mean you're going to leave some really good ideas fallow for a couple of decades? Probably. And that's a shame.
How do you think about scientists that are working either trying to confirm their theories or falsify their theories? You know, that kind of general debate about Popperian, Karl Popper's falsification definition of science. But that isn't really what scientists are doing. Others say it's more Bayesian. They're just trying to pile up more and more positive evidence in favor of the theory to increase your credence in the acceptance of it. And you change your priors because you read a new paper about a new experiment. And that's kind of building a positive assertion or positive evidence for it rather than falsifying. What are your thoughts on that?
Well, I think it depends who you ask when you ask this. People like the idea of Popperian falsification, that's what they're doing. It doesn't seem to me that that's how most scientists behave. That they're actually get an idea and they try to poke as many holes in it and then see it drop. I think the Bayesian picture captures more of what especially a group of scientists in a subfield are doing with each other, where they're engaged in something adversarial. They are trying to critique each other, but really what they're trying to do is build up the plausibility of the priors. And there's what you do to convince yourself that you're right and what you do to convince your peers that you're right. And the great thing about science is it's not really up to you. It's not like you could have a really great idea and you could be really certain of it, but it's not enough. You have to figure out how to make it plausible to other people. And the Popperian model sounds like it works well. It doesn't actually work well when you look at what people do or how people are persuaded. I think both at the level of individual scientists doing their work or otherwise, it's not a good anthropological description. The Bayesian one's much closer, and it also has some philosophical heft to it. So that's my sense of where things are going. I think a lot of people just try to confirm what they think is right. But if they're working pretty close to the consensus and they're careful methodologically, that's not bad science. They're adding more data, and that's a valuable thing to happen. You can accommodate enough heterogeneity in the scientific community to enable people sorting by their skills and their preferences, so that we have robust knowledge being confirmed in lots of different alternative pathways, as you pointed out earlier.
Yeah, so this idea that you could falsify a theory with one good experiment. Einstein famously said in response to that book, 100 scientists against Einstein. He said, "Why 100? If I'm wrong, it just takes one." I always love that quote. But on the other hand, if somebody said, "Look," because J.B.S. Haldane famously said, "What would refute evolution?" Fossil rabbits in the Precambrian. Yeah. So that's true. That would, I don't know if it'd falsify the theory, but it would sure get people's attention. One of my favorite little stories from Steve Gould, when he was either debating or he was addressing one of Duane Gish's, the Gish Gallop, where he'd throw up slide after slide after slide, and Gish had a slide from a mainstream geology textbook about how if you're driving along Interstate 70, I think it was in Colorado, and you pass this mile marker and there's this road cut. And, from your car, you look out, you see the older beds are on top and the younger beds are on the bottom, clearly refuting the whole fossil sequence and of geology, of paleontology, of which evolution is based. So it's obviously been refuted. And then Gould goes to the original textbook, and the textbook guy says, but if you get out of your car and you walk over to the road cut, you can see there's a thrust fault there that flipped the beds over some period of time. Gould's point is you gotta use the whole quote, or maybe more metaphorically, you got to get out of your car. So evolution is so far well supported for so long. A single experiment is not going to refute it. It would have to be a whole series of things showing multiple problems.
And what would it even mean to, the fact that species have changed over time is very, I don't even know what it would mean to refute that. And in terms of refuting natural selection, there have long been complements to that, like neutral selection, sexual selection. There's a whole bunch of alternative, it's actually a very complex and rich explanatory system where sometimes people are like, actually, that wasn't natural selection. That was something else, and we have an explanation for it. neutral selection is one of the weirdest of those. I mean, like, but it is quite established in terms of how bacteria actually behave. So yeah, no, you have to use all the evidence. You have to that 100 Authors Against Einstein was mostly cherry picked quotes. That also had that book has a lot of problems. But not just that gave Einstein a good excuse for a great quote. But the vision of Popper looks really persuasive. It's not very good, but it's fine that it's not really good because we have many other alternative explanations for how science operates that capture the complexity of the operation. It's a very intricate and intertwined human endeavor that has as an outcropping of it that it produces reliable knowledge about nature. It also can spin off fringe theories that of failed ideas, things like astrology, which were scientific once and aren't now. That's another thing it can do. And it doesn't help to ignore the parts of it in favor of the other parts you like. You need to see how the whole thing works so you can get a better picture. That's what we would expect of nature, and it's what we should expect when we look at the scientific community operating too.
Yeah, then on the flip side, a single experiment is not necessarily going to prove you're right or launch a whole new field. Here I'm thinking of Daryl Bem's famous experiment about backwards causality. I've discussed this before on the podcast, but for those of you who haven't heard this, so Daryl Bem's a famous experimental psychologist, and he published this study in a very prestigious peer-reviewed journal, the Journal of Personality and Social Psychology, one of the highest rated in the social sciences. And he had a real lab, so he wasn't one of these pseudo lab pseudoscientists. He's the real deal.
No, not at all.
And and ESP people are always saying, why don't you take us seriously? And we always say, well, you need to run controlled experiments and publish in peer-reviewed journals, in a real lab. And they go, okay, there it is, there he is. Okay, so the experiment is this weird thing where subjects are sitting before a screen like us with a split screen, and and then they have to press a button about whether they think this neutral image is going to pop up or whether this pornographic, emotionally salient pornographic image is going to pop up. And they were slightly better than chance in this one experiment out of 9 that he ran, that they were able to tell which one was going to, before the random number generator selected whether it would be the left or right screen. These subjects were somehow able to do this. The theory being, Stephen Colbert called it extrasensory pornception. Somehow the pornographic image stimulated the neurons to detect, from the future into the past, which one was going to come up on the screen. Okay, this was a crazy experiment. It was ultimately showing to have methodological flaws. But initially, people said, hey, okay, there it is. Why don't you skeptics say, yeah, ESP is real?
But one of the things there's a chapter in the book on this one of the things that I find fascinating about ESP is that every time ESP claims have been around for a long time. Every time they come around, they get debunked, but they get debunked in such a way that it innovates experimental practice. Things like having a placebo sham, things like having randomized trials. Randomized controls is actually something that was created to debunk spiritualism, the table wrapping, automatic writing type stuff. The introduction of many statistical controls were put in when someone has a positive ESP claim and people look at it and say like, oh, here's the methodological flaw. Let's change our procedures to fix that. So BEM is another example of that. Every time there's a positive claim, it actually helps make experimental psychology better because it has figured out a failing, a gap in the methodological apparatus that they had. And it's one of these sort of arms race between the ESP people and the mainstream community that in the end has made the community stronger, even though it makes people very frustrated to have to deal with these claims when they pop up from time to time to time.
Right. So, in fact, it's the BEM experiment that launched the replication crisis because people started to look at other experiments and go, wait a minute, if you ran 9 experiments and you only published one of them, what was going on with the other 8? Maybe you have some, so this p hacking and file drawer problem where you're just filing away in the file drawer the unsuccessful experiments. Well, we need to know about those because those are important too. And so a whole slew of these cognitive priming experiments about, I always use this example, if I hold a glass of cold water and then I meet you, I perceive you to be kind of a cold and introverted person. But if I have a glass of warm water and I meet you, then I think you're a warm, engaging person or something. That was never replicated. Or my other favorite examples, like if you're at the top of the escalator versus the bottom of the escalator, you get more money at the top of the escalator to a donation to a charity, or how messy your desktop is, as a proxy for something else, or the famous power pose that was presented at TED, where if you stand up straight with your shoulders back and chin up and you march in there and ask for the raise, your testosterone goes up and it's better for life and so on. And people walking around in their power poses till this was apparently never replicated or refuted. And anyway, there's a whole slew of these launched by this. But you would then say, well, that's progress. It's scientists that are figuring out what the problems are, and that's how science grows as a community.
And in many of these cases, part of the problem is education about how statistics works within the psychological community had lapsed because the software was getting very good at doing it for you. So the teaching of what's going on behind it, and the conceptual understanding had gotten a little weaker. And so we had outsourced a form of critical thinking into the black box of the computer. And so what it has done is sort of focused attention on keeping your methodology clean, and that things had gotten a little loosey-goosey from the 90s to 2010, and we need to actually clamp down on a lot of this stuff. And that's probably in the long term productive. It is, of course, damaging in that people don't want to go into this science, or it loses status and funding and the ability to train new people in the short term. But I think in the long term, that kind of deep methodological critique, which is often occasioned by fringy, weird claims, it can help science become better by showing it how to avoid certain kinds of cognitive biases or statistical anomalies or things that we hadn't taken into account before.
Right. Yeah. Particularly with social phenomenon, it's, Steve Pinker always makes this point that there's nothing big like religion or crime that's going to be explained by a single factor. So I remember he has a discussion of this in The Better Angels of Our Nature, because I remember when Stephen Levitt published Freakonomics, which was sort of the pop version of his original paper about how the great crime decline starting in 1993 was the result of Roe v. Wade in the 70s, and that there were these mothers, these pregnant mothers who were single moms who were going to give birth to these kids that would then grow up in single homes in crappy neighborhoods and whatnot. And those kids would become criminals. Well, they were aborted, so we had fewer criminals. And, Stephen Levitt, he was a good statistician and economist, and, he laid it all out there, and it looked like it was testable, and a lot of people thought, finally, we have an explanation. It was the Roe v. Wade thing, the single factor that explains all crime decline, from 1993 to, last year or whatever. And so Pinker shows that, well, no, here's the problems. But he takes up like 4 pages of analysis of why this is not correct. But then the bottom line is nothing big like, crime or religion is going to have a single causal factor. And part of the problem in the social sciences, we want to emulate the physical sciences, where they go, oh, yeah, it's super simple. It's just gravity. You don't need all these epicycles of the planets going around and around. It's just a much simpler model, as if Occam's razor, the simplest one is always the right one. Well, that's not true in the social sciences.
Yeah, I think that's generally right. The only partial exception I can think to that is it does seem that once they took the lead out of gasoline, kids got smarter. That there is a real effect that you can see, because it's a neurotoxin, and once you get it out of the environment, it actually does an effect. But that's pretty rare, that you have something that's so sharply clean where you can document the mechanism. What lead does to people. You get it out of the environment. Kids are better.
But is that
rare.
true?
That's rare.
But
I don't know if it's true. I've seen the reports of that. I have not gone in and checked it. I think it will be worth checking.
Yeah, because I read that too. But again, lead is a single factor. Take it out, and then kids get smarter. Well, the Flynn effect. James Flynn discovered this effect of IQ scores going up about 3 points every 10 years for almost a century since we've been recording it. So I did wonder if it's just an artifact of that. Well, they were just getting smarter anyway.
It might be. It's certainly if you wanted to look at a causal effect and see whether there's something, lead seems like a good one because it's very easy to measure, and the signal is very easy to measure, and we know the mechanisms by which it causes harm. So people could do that work. Again, not the skill set I have. So I hope somebody else does that.
Yeah, and then so you also talk about eugenics, and so now we look back at eugenics. Well, that was pseudoscience. And yet still today, there are people that work in, let's say, behavior genetics and intelligence, if we want to go down the path of a pretty hot, radioactive subject here, because of the group differences is what, concerns people politically about the implications of that. But how do you think about, science that has implications like that, social, political implications? And yet some people pursue it and others just don't because it's taboo. And we're in the middle of that. So we don't know that that's pseudoscience, but we could say, well, the eugenics program, that turned out to be wrong. So maybe this one is.
It's very hard to say. Like, I don't know how to judge present day science or present day claims to science. Much of what's published in the present day is going to be wrong just because we're going to learn other things later that change that. Specifically in these areas, it seems like there is a strong and fairly legitimate social pressure that if you're going to make a claim that is incendiary, you need to have really high proof bars. And that seems to me a legitimate thing. Like, we can tolerate in the science a little loose thinking in areas that aren't, again, of public harm or public that could cause public damage. But in areas that where there is a potential for that, you want a really high level of evidence. You want to make sure that everything is really clean. And in the cases that I've seen, the people who make those claims haven't been as careful as they probably should be. And yes, it's a social pressure on science to treat some topics with greater sensitivity and greater methodological care than others, but that's not unusual. That's kind of, science has always had that. And it's that, just like the bar for evolution was for a long time really, really high. You had to really show your stuff, and people did.
Here, I was just thinking of more current hot button issues. Another one, trans. To what extent do we understand biologically what percentage of the population are clearly male, clearly female, or somewhere in between, or trans, or and to what extent that's biological or cultural. And, the trans thing is a pretty hot topic now. 60 Minutes just covered it Sunday night, where they start off interviewing a trans doctor. She herself works in trans medicine and is trans. And, she argued, well, the science is pretty clear. We understand now the realities of it, and we can consult with teenagers who want to transition, and we have all these checks and balances and so on. And she went on and on, like, we have this down. And then they cut to these detransitioners, these kids who just, in a matter of days or weeks were able to get puberty blockers and testosterone and prescriptions for these drugs as underage. And even top surgery, where they have their breasts removed, and now they resent it, and or they were wondering, why didn't somebody stop them when they went through this phase, and and so the particular episode kind of went back and forth on that. To me, it just does.
Well, it seems like there's a scientific question and a social policy question, right? Like, there's a question about what do we know about sexuality, and then there's what should we do to regulate it, which is another question. I don't know what I think about those, but it is very easy to blur, and that blur is something that happens on the fringe a lot, and it also sometimes happens in the mainstream.
Yeah, that's right. I mean, the climate is another example, or vaccines. The science is pretty clear about the realities of climate, global warming, and that vaccines don't cause autism and so on. And yet, when it comes down to policy, then people, maybe resist, wanting to do something, whatever the consensus is. And then you have tensions with, political freedom. Well, I should be free to not wear a mask, or I should be free to not get vaccinated. Well, what about the freedoms of people to not get your bugs, your germs, and so on? Those are always tense issues.
Right. And the science is pretty clear that if we drove slower, there would be fewer accidents.
Right.
We make an agreement about what that level of speed we are going to tolerate is, and we understand that there are going to be certain accidents if we allow that. And we just say if we all drove 10 miles an hour, there'll be way fewer car fatalities, but we're not willing to live in that society, so we sacrifice something for it.
See, those are kind of political decisions. I've been kind of toying around with different truths, this idea of different truths. There's empirical truths, and we should, in principle, be able to get to those. But what about religious truths or political truths? Let's just take my favorite example. Jesus of Nazareth probably really existed. Most of my history of religion colleagues, even atheists, say, yeah, he probably existed. And he was probably crucified. The Romans, they crucified everybody. Okay, so that's not an extraordinary claim. But that he died and came back to life 3 days later. I mean, he was really dead, not in a coma, not some Dan Brown scenario where he gets whisked off to France and has starts a family with Mary Magdalene. No, that he's really dead and then he's really raised from the dead. It seems to me there's a transition in there from an empirical truth to something that's a faith-based. You either accept that or you don't. It's not something that could be proved. Where's the control group? I mean, this would be an extraordinary claim, and so on.
I mean, not everything that we believe has to be scientific, right? Like, so the science is a mechanism for many things we believe, and there are other things like a political system isn't grounded on scientific principles. It's grounded on some kind of agreement about how the society should be organized. And religion seems to me like that too. It's not a set of claims that are grounded on science. It's a set of claims grounded on something else. And people have to it seems like historically you can see that there are these things mutate over time as people change what they're willing to accept and the grounds upon which they're willing to accept them.
Now, I would agree with you politically on certain issues. Say, for example, what's the correct upper tax bracket for the highest earners? So it's about 38% now. It used to be 72%. And Biden wants to bump it up two percentage points. And big debates about that. Okay, what's the right answer? There's no right answer. It's whatever we all vote on, and the Dems won, so they get to have their slightly higher number, and maybe in 4 years or 8 years, the Republicans will win and they'll lower it again. But if you do a pullback and say, but what about, say, between democracy and autocracy? Would you rather live in North Korea or South Korea, or East Germany or West Germany during the Cold War? I think there it seems to me we can make some empirical claims. Like, no, people would actually really rather live in a democracy. And why? Because they really, by nature, would rather have some autonomy and choice and freedom versus not. Or just take something even easier, slavery versus non-slavery. It seems like we've moved in a direction politically that has some grounding in human nature. I think this is a social science question, again, about how we should check the methodology and how we should measure the question. I'm perfectly willing to believe that's a plausible hypothesis. The standards for how to prove it, I think, would be interesting to explore. And then you would have to look at the fact that there are many places where voting has been happening for a while, and then people vote for anti-democratic mechanisms to be put into place. And that's a phenomenon too. And how does one explain that? It doesn't seem like that the ratchet only goes one way. It sometimes goes the other way too. And so this is, again, like you've pointed to this before, a social science hypothesis is very hard to nail down, but we do have a lot of tools, and we are getting better at figuring out how to test some of the ideas we have, but it's unlikely to be a single cause. Yeah. So, and then I was going to ask you about, again, the value of science and empiricism, which we accept since the Enlightenment as, a very powerful tool. And yet by the 1990s, sort of the influence of the postmodernists who themselves were skeptics, we're skeptical of grand narratives that have been told for centuries, and that we should challenge those. Like, yeah, that's good. That's right. That's good skepticism. But then, by the time into the mid to late 90s, we had the Alan Sokal hoax, in which he showed a lot of this was just gibberish. 94. Yeah.
Well,
just a lot of this. Yeah. So what do you think about that?
I feel this is a longer conversation to have. I will say that you wouldn't accept what Sokol did as a scientifically valid experiment, in that he submitted a hoax paper, a very funny hoax paper, to a journal that didn't do peer review, and that published it. And then he said it was a hoax, but it wasn't to a peer-reviewed journal, so it wasn't actually the standards of the field that were being tested, and it's an N of 1. So it's funny, and it's funny that it was published, and it is gibberish. But what does it prove? That's harder to say. The grievance studies attempt about 5 years ago to do this as well, they actually failed to get much of their stuff printed. And they got revise and resubmits over and over again, which makes me, I mean, I am, obviously I have a commitment to this because I'm in the historical profession where a lot of this stuff happens. But it does seem like the standards of the field are more robust than it looks, and that various postmodern theories are tools that are effective in some places to break apart assumptions and get you to think about what exactly is madness anyway. Like, what do we mean when we say that? And let's see if we can investigate a little bit how we've decided what that boundary is. Some of that stuff seems helpful and some of it's not helpful. And again, the test is in the doing, like in the seeing what the result is. But the Sokol case, it's interesting that it got the press it did, but he didn't submit it to a peer-reviewed journal, and I would be curious as to know as why, because I wonder how it would do. But it's impossible to tell now, right? We only have an N of 1.
Yeah, that's right. Well, and the grievance papers adds a few more, but still, it's more of a demonstration,
but
I
suppose. Many more that failed. Yeah.
Yes, that's true. Well, okay. So you mentioned. Wait, what did you just mention? Oh, we're talking about madness. Well, so you're referring to Michel Foucault's book, which I read in graduate school, and I thought, what the hell is he talking about? I mean, the invention of madness. And then but giving it some thought, it's like, okay, I see. It's how people that act differently. The kind of modern term of this is neurodiversity, right? Neurodiversity. Yeah. They're just different cognitively and neurally. And, so society starts locking them up because we're transitioning from this more rural agrarian society to a more urban industrialized society. And you got to do something. These people, they're just homeless or, they're just wandering the streets. We got to put them somewhere. So they start locking them up in these, bedlam, literally, cases and figuratively. And, so I see. So that would be a positive example of a kind of a postmodern interpretation of some actual physical thing that happens in society.
Yeah, most of what happens in postmodern thought is to take a category that has been taken for granted and say, what happens if we mess with it a little and see how robust it is? And sometimes categories aren't that robust. And especially if you look at things on a historical trajectory, what counts as mad is pretty different over time. And we can learn something about how we think about the own way we deal with people that we now call mentally ill, and which of those things like homosexuality not that long ago was considered a mental illness, and now it's not. That's a real change in a categorization that had a real impact on people's lives. And those are places where I'm cherry picking a good example, right? But like you can find lots of bad examples too. But I think that those are cases where that mode of analysis has the potential to just shake up one's assumptions a little bit. It is kind of the skeptical move. It's like, let's take a look and see what happens if we just explore the edge a little.
Well, we're seeing some of this now with, race and gender, that science has historically been done mostly by, white guys. So we need to have more women and people of color in the lab in different fields. I agree. That kind of viewpoint diversity is super important. Naomi Oreskes talks about this a lot in her latest book, What is Science? Why Trust Science? Why Trust Science?
Why Trust Science.
And, so she has lots of good examples of this. And back to the 90s with the science wars, where feminist scholars were saying, hey, we need to have more feminist perspectives on science. And then, there was a lot of pushback by people going, no, there's no feminist science. There's just science. And, we see more of that now. I'll just read one passage from a paper that I originally thought maybe was one of these hoax papers. It turns out it's not. The paper is called Glaciers, Gender, and Science. It was published in the peer-reviewed journal Progress in Human Geography. This is the abstract. Glaciers are key icons of climate change and global environmental change. However, the relationships among gender science and glaciers, particularly related to epistemological questions about the production of glaciological knowledge, remain understudied. This paper thus proposes a feminist glaciology framework with 4 key components. 1, knowledge producers. 2, gendered science and knowledge. 3, systems of scientific domination. And 4, alternative representations of glaciers. Merging feminist post-colonial science studies and feminist political ecology, the feminist glaciology framework generates robust analysis of gender, power, and epistemologies and dynamic social, ecological systems, thereby leading to more just and equitable science and human ice interactions. So, when I read this, I went, what?
Is the paper interesting? There's a classic example from the 70s of most primatologists were male. And what they would do when they were in the field is they would follow male primates around. And so they never followed the female primates around because they figured they weren't important. It wasn't until you started getting Jane Goodall and the next successors that they would actually follow the females around and realize that many of the societies are matriarchally structured. Something totally missed because of the assumptions of the people who came. So I haven't read that paper. What my priors are about what that paper is going to be are a little different. I'm kind of curious now to see whether it actually pays off. I would be intrigued to read the paper. I do have to say, though, that I have to go in a few minutes. So.
Oh, okay. Yeah, sure. Yeah. No problem. Yeah. Yeah. So I was kind of wrapping up there, just to bring these historical issues to the present. These are still viable issues that we're concerned about. Who conducts science? What authority should we trust? And for historical reasons, it's understandable why people of color and women are like, hey, you guys have had the run of the show here, and it's led to some bad science, led to some good science too, but some bad science. So this kind of viewpoint diversity, cognitive diversity is probably good. That's kind of how I see that fitting with your book, which is the larger issue behind.
I think that's totally right. I think that there are obviously ways that can get pushed too far, in the same way that not letting in those people can be pushed too far. So I'm very much a sort of, I think the balance and the dynamism is part of the strength of science, and allowing more of that dynamism in is probably a good idea.
All right, last 2 questions. I just wanted to ask you about some issues that I've been working on that I think may be insoluble. Like, how would a scientific community address the hard problem of consciousness, free will and determinism, where the universe came from, why there's something rather than nothing? It seems like at some point we may hit, just the unknown unknowns that are unknowable or something like that. We're just not capable of solving certain conceptual problems.
I think it's when you get to those hard problems, that question about how much of the fringe you need to let in becomes more actual, because you get stuck. And the question is, do I have to let in more of that fringe and entertain some of the weirder ideas or not? And I think on those problems, you make that decision of, yes, we should, or it's okay to be ignorant about this question and just leave it frozen for a while because it's not worth the resources. But I do think you will hit those boundaries. We've hit them in the past, and we've made choices about how weird we want to get in terms of thinking around them.
Yes, well, again, a century from now, people may look back and go, I can't believe these crazy ideas they accepted in the 21st century. All right, last question, because I know you think about these things a lot, and it's a practical question. How do you talk to a climate denier, a anti-vaxxer, somebody who doesn't want to wear their mask, or on the other side, they deny GMOs or nuclear power or whatever, or even just a creationist, just somebody on the fringe? How do you talk to somebody like that?
I think you want to figure out where they get their evidence from. Like why do they believe the things that they believe, and then once they have the evidence, why this explanation they have makes more sense to them, and start from there. That's you taking the evidence seriously, seeing what it is, and in some cases, you can offer a better explanation for their evidence than they have, and that satisfies the problem. In some cases, you're just not going to succeed. It's just not going to work. But I think that approach of being like, why do you think that? And what does it do for you? Why is it a satisfying explanation for you? Can at least give you a sense of empathetic understanding of where they're coming from, but also may give you a tool by which to continue the conversation and figure out why it is that they took the path they took. And if you think they need to come back to your path, how you might get them there.
Yeah, you make a comment in your book about to what extent the skeptical movement has an effect. It's hard to measure in time series polling data because the numbers are pretty stable over decades. It doesn't look like we're becoming more skeptical and scientific and rational. But the subjects change. Astrology goes down, but flat Earth goes up or whatever. It seems like it's a hard problem for in terms of a long-term rational Enlightenment society. We're always going to have, it seems, these kinds of fringe ideas.
Yeah, and the question is, where are they doing damage, and what kind of damage, and therefore how should we focus our efforts on them? And then they seem to be intrinsic to how we live. So how can we live with them? What is it that's causing them to come from? How can we prevent them from making things really bad? And maybe it's the case that it's not just whack-a-mole with the skeptics, that if you guys weren't doing your work, the net amount would have increased. Like, instead of being stable over time, it would have had a different tilt. It's hard to know. Again, we can't run the tape twice.
All right, Michael. Well, thanks for your work and thanks for your new book. What's next on your research and writing agenda?
A little bit of a break from this. I'm looking at what happened to global science when the Soviet Union collapsed. Like, when this very large scientific community vanished, what happens to the people, what happens to the stuff, and how do all those various countries restructure science after that collapse? So a different set of questions, but again, about how science operates. And thank you very much for the conversation and for the invitation. I've really enjoyed this.
Really interesting stuff.